Some quadratic equations are the products of two binomials. With those types of quadratics, the techniques of factoring provides a simple way of solving the equations. In this video, we look at examples of solutions to quadratic equations that involve factoring. Let's start with an example. The area of a rectangle of unknown length and width is modeled by this equation. A equals x squared plus 9x plus 20. The quadratic expression is the product of two binomials that make up the length and width of the rectangle. What are the dimensions of the rectangle? We want to rewrite the area formula as the product of two binomials, as shown here. If we expand a factored quadratic, notice what happens to the a and b term. The sum of the terms becomes the coefficient of x, and the product of the terms becomes the constant term. Now let's look at our quadratic. We've highlighted the 9 and 20. What we want to do is to find the factors of 20 that add up to 9. Here are the factors of 20. 20 times 1, 10 times 2, and 5 times 4. Each of these factor pairs equals 20. But there's only one pair that adds up to 9. And that's the factors 5 and 4. We can now write the original quadratic expression as the product of these two binomials, x plus 4 and x plus 5. And these binomials are also the dimensions of the rectangle. Let's look at another example. The height of a triangle is 2 units longer than the length of its base. Suppose the area of the triangle is 24. What are the possible dimensions of the triangle? Here we are given the relationship between the height and base of a triangle, along with the area of the triangle. We know that the area formula for a triangle is 1/2 base times height. If we assign x to the base, that means the height is x plus 2. Substituting these terms into the formula, we get this for the area of the triangle. Furthermore, we're told that this area is equal to 24, which results in this quadratic equation. First, multiply both sides by 2 to get rid of the 1/2. Next, move the 48 to the left side of the equation, which changes its sign, and we are left with this quadratic equation in standard form. Can we factor this quadratic? If so, we need to find the factors of -48 that add up to 2. There are 8 possibilities for the factors of 48. All of these factor pairs result in a product of -48. But only one pair has a sum equal to 2, and that's the -6 and 8. So we can factor this quadratic. Here is the quadratic equation in factored form. We get the solutions x equals 6 and x equals -8. Only the positive solution makes sense. So if 6 is the base of the triangle, 8 is the height. Let's look at a final example. The area of this square is expressed in the following quadratic equation. A equals x squared minus 16x plus 64. What is the minimum whole number side length for this square? What is its area? Because this is a square, then it will factor into a single binomial squared. The negative coefficient of the linear term shows that we're looking for a factor of the form x minus a. The square of x minus a results in this form of an expression. So take the quadratic that we're given and turn the linear coefficient into a product of 2 and another number. So 16 becomes 2 times 8. Then write 64 as a square number, or 8 squared. And sure enough, this quadratic can be factored into the single binomial x minus 8, which is then squared. When x is equal to 8, the area is 0. So the next whole number amount for x is 9, which makes the side length 1. The area is also 1.